Good evening, everyone. My name is Maria. I'm the coach of Siemens ITP IoT team. First, I would like to thank our customers, Mr. Johan Niklas and Dr. Makuzawa, for being here tonight with us and for helping us during the entire semester and supporting us during the development of our project. Our team consists of our team leader, Andreas, our 6 developers, Alina, Anil, Dimitri, Flo, Frido, and Nicola. So now I would like to pass the stage to Frido, and he will tell you more about the system we developed.
Good evening, everybody. About 100 years ago, a typical factory with production line looked like this. Everything was analog and manually operated. The only smart component were humans. Since then, a lot has changed. Nowadays, a typical production line looks like this. Everything is digital, interconnected, and runs largely automated with little human interaction. Every machine has myriads of sensors producing valuable information about the state of the production line. All of these information are, of course, accessible either directly at the machine or through some centralized monitoring tool. So, what if you're standing in the middle of the factory and you want to retrieve all this data gathered around you? You could, of course, go to every machine, check their state, or you could open your laptop, dig through some interface until you finally found the machine which is right in front of you. But this way of information retrieval is neither quick nor context sensitive. So, wouldn't it be cool to stand in the middle of the factory and retrieve all the relevant information about the condition of the production line in a universal language everybody understands? For that, we created Emoji, an application using emojis and augmented reality to provide context-sensitive information about the state of the production line. By just using your smartphone, you are able to observe the state of every machine in your surroundings. For the implementation of Emoji, the following requirements were elicited. First, we need to detect and identify industrial IoT devices responsible for the collection of sensor data. Then, of course, we need to retrieve the measured data, and the data needs to be analyzed and visualized. Also, the user of the application wants to be notified about critical events occurring inside the production line. For example, if the operating temperature of a machine leaves a predefined threshold. Besides these functional requirements, there were also some non-functional requirements. The system shall be extensible, for example, to be able to visualize arbitrary types of sensors. Also, the system should be easy to use and understood by any user. Now Flo will elaborate on how we managed to implement these requirements.
Thank you very much, Frido. So, this is when we talked last. This was our last top-level design. And since then, in the phase of implementation, we saw that there was room for improvement. So, for instance, usually you use a fog node to reduce the latency from data coming from the cloud to the smartphone. In our case, we only retrieve historical data, so it turned out to not be necessary. We therefore only send the historical data from the fog node to the cloud and then have a new direct channel from the cloud to the smartphone that can deliver the historical data directly to it. This direct channel also allows us to fulfill our requirement after notifications. If you wanted to deploy Emoji in your factory, you would have to, of course, deploy the fog node, which is represented here with the Intel NUC, the black box on the left. And you, of course, also would have to provide all of Siemens' IoT devices that read the actual sensor data. Last time we talked, we used QR codes to visually identify the IoT devices. We thought that was not the most seamless solution, so we worked really hard to improve it. Now we have little LEDs on the devices that help us with our iPhone to visually identify them. Now, it looks like I'm getting a notification. So apparently one of our data transfer rate sensors in the machine room is out of bounds. Let me call my colleague to fix this. Morgan, are you there?
Yeah.
Can you, one of our sensors in the machine room is out of bounds. Can you please take a look at that?
Yeah, on it, sir. Yeah.
Perfect, thank you.
Who does he think he is? I've been demoted because I drink a lot, but who cares? Okay, just send in a new guy. Just send him in.
Sir, you called me?
Yeah. What's your name?
Mikola.
Mikola.
Yeah.
Your first day?
First day on the ship.
Yeah, okay. So you're supposed to diagnose stuff and fix them, okay?
Okay.
All right. So let's get you ready. The first thing you need is not this.
Okay.
Okay. Now you need the phone.
Okay.
All right. Just turn it on.
Yeah.
And all you have to do is just open the app and point it at stuff.
And these are the actual devices we will be working with?
Yeah, exactly. But first of all, let me remove this because we don't need this stuff. We used to use these, but not necessary anymore. Okay. All right. Just good job. Right. Do it slowly. Don't do it too fast. Nobody can see.
Yeah.
Right. Good job. Now just take a step back. Right. Now, first of all, let's start with detection. Do you have any idea how this works?
I don't know. I feel like it's mocked, right?
Yeah. Okay. Here we go again. Okay. Initiate training sequence 156. Here we go. Now just divert your attention to this. Okay. I'll explain to you. Now the first thing we need is a machine learning model to identify a device. Okay. And then once we identify it, we have to be able to know which device we're looking at. And for that, we're using lead detection. Okay?
Okay.
But the lead detection has to be within the bounding box. Otherwise, we have too many lights going on. Who knows what's going to happen, right? So now we're done with that. The second thing we want to do is emojis, right? That's the whole app.
Yeah.
Now, can you basically tell me what you think? What is this stuff?
I don't know. When I look at the word drive, I feel like something is wrong because the face is not really happy. I mean, it's happier. Yeah, it changes.
Yeah, exactly. So the big emoji is the internal state of the device, all right? And the small ones are basically sensors connected to it. And this is all happening in real life. So if everything's out of bounds, if something's out of bounds, then you'll see that emoji for it. That's power consumption. That one is high temperature. And that's really easy. Just diagnose it right away, right?
Yeah, really intuitive.
All right. So let's swipe right for labels. So these are actual values, numerical values coming from the sensors, just so you know what they are and they'll give you an idea, right?
Yeah.
And then let's move back to the emojis and just tap on one. Just tap on it. Good job. Now, this is streaming from the device in real time. Now we can just turn them on and off because sometimes you just want to know if something's correlated with other temperatures, right? Exactly. Now we can turn off streaming and zoom and drag, and we can share that, but I'll get to that in a second, all right?
Yeah.
All right. Now, let's go into historical data. Now, why we need this stuff? Well, sometimes it's just nice to look at historical data, right?
Right, yeah.
But more importantly, it's because we want to know if something's happening periodically. Like if something is breaking every once in an hour, right?
Yeah.
We can just filter it, starting from the last 30 minutes all the way up to the last day. And yeah, we can edit the sensors just like we can in the streaming chart.
And the data will be stored anyway?
Yeah.
Or should I use
So the data is actually stored, saved to the cloud, and then processed and analyzed and then sent back in like meaningful chunks. So you don't have like millions of data points.
Okay.
Right. So let's move on to sharing. That's the one I want to talk about. So we have standard sharing, which just sharing, email. And then we have a sharing method using AR, which is pinning the graph for now. Just pin it. There we go. So this is actually being shared with others. So if I were to come up and scan the device using my phone, I would actually see this. So this is a way of communicating in AR, right? Mm-hmm. It's just an image, but it could be a sound file, it could be some link, it could be anything. So if you want to get rid of that, because sometimes it'll get fixed and you want to delete stuff, just tap on it. That's all you have to do. Perfect. There we go. Delete that. And now it's actually deleted from the service, so nobody will be able to see it ever again. Okay, the last thing I want to talk about is notifications. Just top right. Top right. Come on. It's taking some time. It takes a while, does it? There we go. Okay, so these are all the notifications that we've received because that device was subscribed to some things. And we can actually tap on one of those. Yeah, there we go. Okay, so that's when that happened. Whatever, it's just some device. It's your job anyway.
Yeah.
Okay, let's go back to the settings. Right, so these are all the devices that we subscribed. And we can actually subscribe to a device, so we can subscribe to any sensor, okay? There we go. Now, the reason for that is because I don't want the captain to call me every single fucking time, all right? So
Yeah.
you just fix it, and then you get notified if something goes wrong. Okay. So every time you fix something, just subscribe to it.
Yeah.
Okay?
Yeah, I mean, it's pretty intuitive. I think I can manage it.
Right. Okay, so that's easy enough. And if anything goes wrong, I'll be in my office, and we'll have some drinks later, all right?
Okay.
All right, good lad.
See you, sir. Bye.
Bye.
Thank you very much. So this is Emoji. You've seen you can do a lot of things with it. Last time we talked, this was what we did at DR. So we were able to retrieve sensor data, we were able to detect the device using QR codes, and we were also able to visualize the status with emojis and graphs, and also with labels in AR. Since then we worked hard. So in the infrastructure department, we can now query for historical data, we can receive push notifications, and also share all the graphs in AR. In the detection department, we can now use machine learning to visually detect the device, and then advanced identification, such as LEDs, to identify it. This has some room for improvement, though, and is not the robustest method in the world, so we're still working on improving that one. Lastly, in the visualizations department, we now have a really good UI design, but we're still working on visualizing the interaction between two devices. That would be it from us. If you want to have a quick peek into the future of diagnostics, please join us at our booth afterwards. And if the customer has any more questions, please feel free to ask.
First of all, many thanks to the team and many thanks to all your engagements. Yes, as you see, I'm really surprised. There was a lot of improvements in the demo and in all these use cases and features. Yes, what I'm interested in, you already mentioned it, how would you do it and what would you do to augment all this interaction between the devices? What are your ideas to show the data streams, the event which could happen between these devices?
That's a very good question, Jochen. I'm glad you asked. It turns out we had some spare time last week, so we might have one more thing actually. So we have the demo back up, and if you give us just 1 second and we detect the two devices, you should be able to see the transmission here of the packages. So it turns out there's not much more to do than what we already did, so you can use that feature as soon as it's released.
Thank you very much.